So those are just some of the new features within this update to AirModView and AirMetView, including the update to the AirSurface utility. So you now get access to the 20060 version of AirSurface. You'll have that station locator utility within the preview window. The land use viewers displayed after the run. The sectors are highlighted. You can have the single download button of EPA recommended files automatically imported into your project, and the addition of the 2016 data via WebGIS. Use of shape files within the land use creator, and then there's a number of other features not highlighted here and incorporated into AirModView. One thing I will mention about the WebGIS updates, you do have to be in current maintenance to continue using those features, as well as the import of the Lakes Satellite Tile Map server. And finally, we wanted to make a special announcement here. We've had numerous inquiries into online training opportunities. Of course, we're not going to be holding any in-person training for a while as we continue to watch and monitor the pandemic situation globally. So we're going to be offering an online AirMod training course. This is going to be our standard 2-day AirMod training, just as you would receive in person, but it's going to be entirely online. Our registration for that will be coming soon, so we want everybody to keep an eye out for that announcement, but the dates are going to be June 23rd and 24th. You'll still get all of the same hands-on instruction. It's just going to be via webcam and audio, and there's avenues through the process that we use to conduct these training courses to where we'll be able to share the screen with you. I can take control and help you work through any questions you have. So we hope to see some of you register for this coming up once we make the registration available. As we approach the end of our webinar, we have a little bit of time for questions. There is a questions box so that if you have any, you can submit those through there, and I'll take a moment to answer those. And for those of you who do need to get going, we don't want to hold you since we said this was going to be a 30-minute webinar, so just let me extend my thank you to you for attending today. Again, my name is Michael Hammer. If you have any additional questions beyond what I address here at the end of this presentation, you can email those to support@weblakes.com. If you have any sales inquiries into updating your copy of AirModView, purchasing a new copy of AirModView, or just checking to see if you're currently in maintenance, you can send those to sales@weblakes.com. So the questions that I have here, one person wanted to know more about the ZOF utility. So within AirMet, there are now 2 different ways to calculate surface roughness. Switch back to one of my sample projects here. And under the surface roughness tab of the AirSurface utility, you see there is the default ZORAD, which is surface roughness radius calculation method, and that just uses a default radius of 1 kilometer around the MET station to perform the calculations. It can, of course, be sector-based, as shown here. The experimental method, ZOF, or effective roughness methodology, is based on knowing the anemometer height. So you input that here, default value is 10 meters, and then an internal boundary layer factor. The default factor is set to 6 based on a recommendation from the AirMet User's Guide. This method is considered experimental, and for testing purposes, it's not fully approved yet by the US EPA, but it's just a different method of calculating surface roughness based on something called the gust factor method. And it uses a varying radius for each individual sector based on what the upwind's land cover looks like. So that's something you can certainly play with. It still uses the same sector and airport definitions as the ZORAD method. It's just something that is in there for testing and evaluation purposes at this point. And someone asked, is 1 kilometer the default radius? Yes. For that default ZORAD method, you will use a 1 kilometer radius. It accepts values as shown here from half kilometer up to 5 kilometers, but using anything other than 1 typically is going to require regulatory approval. Someone asked, are there any changes in methodology to calculating the surface parameters unless you select the testing-only surface roughness option? Pretty much no. The internal calculations for AirSurface have not changed. They remain the same, and any modifications to the parameterization of each land cover category is coded into the model itself. So any modifications made by EPA to, say, the surface roughness value of grassland in a particular season, that is done internally to the code itself. Those can be found within the Air Surface User's Guide as published by the EPA. Other options that would be considered non-regulatory besides that ZOF roughness method would be how the files are combined. So if you were to use land cover with just canopy, that's considered non-regulatory. If you were to use impervious only, that's considered non-regulatory. They would prefer that if you're going to use the products in concert with one another, you use all three products or just the land cover product, and that you match up the years, as I mentioned before. In general, is there a reason to use early land use data? I think of newer data being more accurate. It depends on what years you're processing. Ideally, the way that you would utilize the different products from the NLCD data sets are going to depend on what years you're processing in AirMet. Generally, most users are going to be modeling the most recent period of years, whether that's 1 year, 3 years, 5 years. Then in that case, if I'm running, say, 2015 to 2019, I'm going to use the 2016 data set since that's going to most accurately represent the area. But there may be cases where you need to model earlier years, whether that's, say 2001 to 2005 or something like that. And in those cases where you're modeling earlier years, it certainly makes sense to use the earlier data products. Or if you're modeling in a region like Hawaii or Puerto Rico where they only have the 2001 land cover data, then you would go ahead and use those. One last question that I'll take, and then I'll let you all run, is do you have to give any justification to differentiate between the airport and non-airport sectors for an airport-based Met tower? It's pretty subjective at this point. So as I looked at that earlier case with Hawaii, where I said, the western half of my 1 kilometer radius was non-airport and the eastern half was, what you're primarily looking for are impervious surfaces, man-made surfaces that are flat, like runways, which of course are dominant around an airport. And a lot of times, like the Reno Tahoe case that I showed earlier, if you zoom in on that particular location, go back to my air surface utility here, as I zoom in on my roughness radius here, I can see that the Met Tower is located right in the middle of the runways. So in this case, I'm going to go ahead and define pretty much all of these sectors as being at an airport. And what effect that's going to have is for all of the developed land that encompasses these flat runways and these streets, it's going to flatten that even more inside the calculations. Where you would identify a non-airport sector is perhaps if I'm looking at this particular location, if I look at maybe Sector 9, I'm going to have a terminal building here. I'm probably going to have hangars around that sector. That may be a sector where I could get away with calling it non-airport. But if there's ever any question of that, of course, you can always refer to the local reviewing authority to get their opinion on the matter. And that's going to do it for us today. I don't want to keep you all too long. If you have any additional questions that come up, of course, shoot those emails over to support@weblakes.com. Thank you all for joining us today. I hope you have a great day and continue to be safe and healthy.